the substitution rule. We will see inshallah together what is the substitution rule and how to apply it for definite integrals, and of course as well as the indefinite integrals. Please, ya shabab, also one issue that I always mention to you, please try to, if you want to ask me, just raise your hand and open the mic and ask. Don't write on the chat, because usually I cannot follow the chat at the same time. Finally, not I think today, next class, inshallah, we will learn how to integrate odd and even functions, how to get benefit from this property. So integrals like these are not now easy for you to integrate. How can you integrate this? It is not direct. All what we know now, you need to ask yourself, what is the function that if I differentiate, I will get this? So this is the antiderivative of which function? What is the antiderivative of this function? What is the antiderivative of this also? So it is not direct. Look at tan, for example. The integral of tan. Did you ask yourself what is the function that its derivative is equals to tan x? So today we will learn how to find the integral of tan x and cotan x, of course. Now to evaluate or to find these integrals, we need what is called the substitution rule. We will see what is it. But before that, I'd like to ask you this question, Shabab. What do you think? In your opinion, what is the most important rule in the differential calculus in Math 101?
Chain rule.
L'Hopital rule.
L'Hopital rule.
L'Hopital rule and chain rule.
L'Hopital rule. I want one rule only. Is it L'Hopital rule or the chain rule or another rule?
Chain rule, I think.
Chain rule.
It is a chain rule. It is the chain rule. For people for who said the L'Hopital rule. In the L'Hopital rule, what you will do? You will differentiate numerator and denominator. So to differentiate, you need what? You need the
chain rule.
It is the most important rule in Math 101. If you don't understand it very well or you cannot apply it, you didn't study Math 101. The chain rule that you have studied in Math 101, here we will call it the substitution rule. In the case of integrals, this rule is coming from the chain rule, as we will see together. So now here we are. This is the chain rule. If you want to differentiate, for example, u to the power n plus 1 over n plus 1, what you will do? The derivative will be n plus 1 times, this is 1 over n plus 1, the constant, this is the constant, times u to the power n plus 1 minus 1. So you will have u to the power n. And because u is a function here, u is a function of x, you will have du dx. This will be cancelled with this and you will have this. This is the chain rule. Now, what will happen if we take the indefinite integral of both sides? If you integrate both sides, what you will have? So now I will integrate this. Here it is. We will have this. Why? Because this is the fundamental theorem of calculus. If you have the derivative of a function, let's say g of x, whatever, I don't want to confuse you. Let me use another notation. So if we differentiate this, the answer will be h of x plus c. This is the second part of the fundamental theorem of calculus. Now, this is exactly what we did here. When we differentiate this with this, we will have it as it is. Okay? And this is the integral of this. So now, you know, Shabab, when we have the integral sign, when we have here dx, we can think about dx like the differentials. You remember the differentials that you have studied in Math 101? So it is, you can think about it like a number that you can cancel, you can divide, you can multiply by. So you can think here like you can think about it this way. You can just like, you will cancel this with this. So you will have the integral of u to the power n dn equals to this. And this is just a kind of generalization for the one that we have studied before, the power rule. We have the integral of x to the power n. The integral of x to the power n dx equals to x to the power n plus 1 over n plus 1 plus c. Here we have x dx. Here we have u du. So here it is u, the same way. So what is here, what is new here, that we have u as a function of x. So what is u? U is g of x. This is u. So g, let's say it is a function of x, so it is g of x all to the power n d g of x equals to g of x all to the power n plus 1 over n plus 1 plus c. Simply like that. So if you have u to the power n, let's say g to the power n. If you have here dg, not dx. dg here, it means the derivative. dg, you know from the differentials, ya shabab, what is it? What is dg? It is g prime of x dx. This is what we mean by dg. It is equal to that. So let me generalize this. This is, of course, when you have something to the power, when you have something to the power n. What about in general, if you have a function, or let me start with this example also to illustrate the idea. So look here, how to find this integral. If you notice, because the product is commutative, you can write it this way. You can just interchange the order. Now, if you notice that if you put this as u, if you use this substitution, what will be du? What is the derivative? Usually we call it du dx. This is the derivative. It will be 2x. But in the case of when we have the integral sign, we need, ya shabab, dx. So we will deal, as I said, we will deal with these dx and du as differentials. So we can write it as du equals to 2x dx. Just it looks like you will multiply both sides by dx if you want to consider it like that. Okay, so here directly what we will, when we integrate here, we will integrate it as differential. So we will say du equals to 2x dx, just like that. No need to write du over dx. Is it clear? This is very important at the beginning. Now, if you notice, if you did that, look here, this will be what? This will be the square root of u, because we bought this as u. And this x dx, or 2x, sorry, 2x dx, what is it? It is du. So we will now have an integral of square root of u du, and this is easy. This will be just the square root of u to the power half du, and this will be u to the power half plus 1 over half plus 1, which will be plus c, which will be u to the power 3 over 2 multiplied by 2 over 3 plus c. And you need to return it back because you substitute, so now substitute back. What is u? u, it is 1 plus x squared plus c, all to the power 3 over 2. Now this is the integral of this one. You can write it, of course, in terms of integral if you want. You can differentiate if you want to check, differentiate this and check if you obtain the original integrand function or not. So this is just as an introduction, small introduction for the substitution rule. Now, what about in general? If we have a function in general. So here, if you notice, ya shabab, what do we have here? We have the square root of something, and here we have the derivative of that thing, okay? So think about u and du, about g of x, a function of x, and the derivative of this function. So in general, if you have the integral of f of g, and here you have the derivative multiplied by. So you have a function of another function, and you have the derivative of the inner function here next to this multiplied by. In this case, you can use the substitution rule. What you will do in this case, ya shabab, you will say this is f of u. So you will put u equals to g of x. And what will be du? Du will be g prime of x dx. So here, what is here will be du. So this is the idea of the substitution. And of course, you can write it in terms of the antiderivative. If you remember from the fundamental theorem of calculus, this f small, if we have its antiderivative f capital, then you know that the derivative of the antiderivative is equal to the original function. So you can write, instead of f, you can write f prime. And of course, the answer here will be f of g. And why is that? Because this is the antiderivative. If you differentiate this, you remember how to differentiate this by the chair rule. If you differentiate this, you will differentiate the outer minus or multiplied by the derivative of the inner function. Now, as I said, I did this before. If you put u equals to g, then the du will be g prime dx, and you can write this integral as I mentioned later. Now, of course, you know that this is the antiderivative, so this will be at the end f of g of x plus c. I think it will be much easier to have it with examples. So this is now the substitution rule. Let's read it together. If u equals g of x is a differentiable function whose range is on interval and f is a constant function, continuous function. It is continuous function on the same interval. Usually it is the domain, of course, of that function or the interval that we're integrating on if we have definite integral. Then the integral of f of g, if it is multiplied by its derivative, if this expression is multiplied by the derivative of the inner function, then this is equals to f of u du. What is u? U is g of x. And of course, you know that if u is g of x, then du is g prime at x dx. We consider them as differentials. Now, to make it easier for you, Shabab, to apply this rule, what you need to do, you need to substitute u equals to g of x, and then du will be g prime of x. I think no need to this step. It's clear that du is g prime. I mentioned it there. Then you will have integral like this. Now, what you need to do when you have integral like this, think about it like when you have f of x dx. So here you will integrate with respect to x. Here, integrate with respect to u. And then at the end, replace u by g of x in the result. As I said, Shabab, before, this is just a kind of chain rule, but in the integral form. And also we have operate here dx and du as differentials. Example number 1. Now you have to be careful when you apply this rule. Now, when you have this, keep in mind, what is the function of another function? This is the first question that you need to ask yourself. Then you need to ask yourself, what is the function that I will put it equals to u? Of course, this one. So here, if you look at this, you have a function here of another function. So here, if this is f, this will be g. But if we put this as g or as u, if we put u equals to x to the power 4 plus 2, what is the derivative? Do we have it there? So let me just write this. You can write this integral like this to be more clear for you. I will just, because the multiplication is commutative, I will write x cubed here. So now, if I put this equals to u, what is du? It is 4x to the power 3 dx. So here we are. So this one will not be exactly du, x cubed dx will be du over 4. So this one, I can continue now. I can write this as cosine. This one, I called this as u. And this one, I will replace it by du over 4. And this is, of course, constant. It can go outside of the integral. And I will have cosine u du. And you know what is the integral of cosine u du? Cosine x dx, cosine whatever du, whatever. What is this? It is 1 over 4. What is the integral of cosine u?
Sine u.
Sine u or negative sine u?
Negative.
Sine, positive.
Sine.
Always, ya shabab, check your answer. Don't mix up, ya shabab. If you have cosine u, its derivative is negative sine u. This is the derivative, but its integral is sine u, not negative. Because if you differentiate, you will get the original function. If you have negative here, you will not have the original function if you differentiate. That's it. Now what you need to do, just replace u by what? By x squared plus or x to the power 4 plus 2. Is it understood, ya shabab, or I should repeat? Let me repeat this example because it is important for you to get the idea with easy example. So here what we will do, we will put this equals to u, because I said we need to have here f of a function of another function multiplied by the derivative of the inner function. If we have something like this, we will use the substitution rule. If we don't have the derivative, we cannot apply it. For example, here, if it was like that, let's say it is the integral of only cosine x to the power 4 plus 2 dx. You cannot solve this one. You cannot find the antiderivative, at least by the substitution rule. It is not easy here to apply. You cannot solve this integral. You cannot find the antiderivative of this function easily, if it exists or not. Even if you have a very easy function, just think about e to the power x to the power 2. Very easy, you can think about it. You cannot find the antiderivative. You cannot find this integral. Because you don't have, if you have here x or 2x, you can't do that. Because this will be the derivative. This will be, if you think about it, it will be just e to the power u du. And you can integrate it. Here you cannot have it without having the g prime here. So it is very essential to have the derivative inside the integrand function. Here, without this, it is not easy to solve. It will not be possible to find the antiderivative directly or by the substitution. These type of functions, we will see later that we cannot find the antiderivative of all the functions, of course. Now, as I said, we will just put u equals to the inner function because I have noticed that its derivative is here. If you have a constant, only a number that is missing, it is not difficult. You can divide or multiply by that number. So here, what you want x to the power 3 dx. Here we are, this is x to the power 3 dx. Just replace it by 1 over 4 as I did. And you can continue, and I did that, and you can see the solution. There is another way, but I don't like it, but maybe it will be okay for some of you. Look here, if you just realize that you have x cubed dx, here it is, you can replace it by 1 over 4. But let's say that you didn't realize that. So what you did, you put u equals to x to the power 4 plus 2. Then you find du, it is 4x cubed dx. So now what you want to do, ya shabab, you will replace this by u. So here we are. Now you need to replace dx to be du, because we wanted to integrate with respect to u, not with respect to x. So we need now to know what is dx. So here you can solve this for dx. So just divide. It will be 1 over 4x to the power 3 du. Okay. So now you can come to the integral, to this integral. So it will be the integral of x to the power 3 cosine u multiplied by dx. dx is what? 1 over 4x to the power 3 du. You can cancel now this with this. And this constant will go outside, and you will have the integral of cosine u du, which is the same as this step. But here you had an additional step. But it's okay for you if you want to make sure that you did it in the right way. Any question, Shabab? We will have another example now. In this example, again, it is not straightforward to find it. But of course, I'm sure that after like 1 or 2 weeks from now, you will be able to evaluate these integrals immediately. If it was like this, Shabab, what will be the answer? Do we need a substitution here?
No.
No, it will be just x to the power half dx. It will be x to the power 3 over 2 over 2 over 3 plus c. Am I right?
Yes.
The same if you have it like this, x plus 1. Do you need a substitution here? Let's say that you thought about the substitution. You thought about putting this equals to x plus 1. What will be du?
1
1
1 what?
dx.
dx.
1 dx. So in this case, we will have du equals to dx. So what is the benefit of the substitution if you have du as the same as dx? No need. So in this case, if you have du is the same as dx, it means that you don't need any substitution. It will be just clear that it will be the same here. Look, it will be 3 over 2, 2 over 3. If you want to check by differentiation, differentiate this, you will get this. So if du is the same as dx, you can use the substitution, of course, but it is useless, okay? But here, if we think about putting u as 2x plus 1, what will be du? Du will be 2dx. So here I have dx, but I don't have 2. This 2 is not a problem. I will divide both sides by 2. So dx will be 1 over 2 du. Now I will come to my integral. I will put instead of 2x, I will put instead of 2x plus 1, I will put u. Instead of dx, I will put a half du. The half go out because it is a constant. This will be u to the power half. Add 1 and divide by the new power, and here we are. This is the integral. As you can see, ya shabab, the substitution is not unique. You can use many substitutions, but of course, you have to be smart and use the best one, or the easier one, or the clearer one, or the one that is reduce the number of steps and calculations. There is another solution. And again, don't forget to substitute back. There is another way. You can, instead of putting what is inside the radical, if you put just the radicand equals to u, now you can put the whole radical equals to u. And you need, in this case, to recall how to differentiate the square root. Do you remember how to differentiate? What will be du? Du will be 1 over 2 square root of 2x plus 1 multiplied by the derivative of 2x plus 1, which is what? 2. This will be cancelled, and don't forget dx. And here we are. You will have dx over square root of 2x. Now you don't want, what do you want? You want dx, because I need to know what is dx. So multiply both sides by the denominator, and you will have dx. Here is dx. Dx equals to this. Now, but what is this? This is u. So now what you have dx equals to u du. Now you can go to the integral. Go to your integral here. What you will have? Let me write it here. What you will have, this will be equals to what? The integral of, what is this? This is u times, what is dx? It is u du. And in this case, we will have u squared du, which is of course u to the power 3 over 3 plus c. It is easy to be integrated. And substitute back, this will be 1 over 3, the square root of 2x plus 1, all to the power what? All to the power 3 over 2. And if you know, over 3 to the power 3 plus c. And if you notice, it is the same as this. The same result. It might be written just in different way. Is it clear, this substitution? Which one you think is better, the first one or this one?
The first one.
I think the first one is better. I do agree with you, yes. By the way, there is another way to make this substitution also easier. What is it? To put u squared equals to x, not u equals to the square root, to make the differentiation easier. Now it is easy to be differentiate this one, ya shabab, because here you will just apply the implicit differentiation. What is the integral of the derivative of 2u? It will be u squared. It will be 2u du. And the derivative of 2x plus 1, it is 2 dx. So what we did here, we just apply the implicit differentiation. Now to find what is dx, just divide both sides by 2. And here we are. We have the same result, but of course with less calculations. In both cases, if you use this or this, you have it, of course, you will have the same integral that as I solved that for you. Any questions? Yes.
Yes.
Nawaf, your mic is not good. I cannot hear you.
Should I know all the ways?
Of course, it is better to know all the ways. Try to do your best, ya Nawaf. Of course, this will come, ya shabab, with experience. When you solve so many exercises, you will learn this experience, and you will have the sense of substitution. Okay. You will be able to choose or to decide which substitution is better, but you need to practice more. Let's take this example. For example, here, what do you think? What is the best substitution that we can choose? By the way, if it doesn't work, we can choose another, go to another substitution. Any suggestion يا شباب here? Again, think about u and du. If you have both of them here, think about g of x to put and g prime. What is the u, that the best u that we can choose here?
We put u minus 4x squared.
This one. Because
Yes.
here, Shabab, we should recall the substitution rule. The substitution rule says if you have a function of another function multiplied by the derivative of the inner function, then you can integrate this by substitution and it will be like this. This is the u and this is u. Now here in our case, if we bought, this is our f, this is the function that we are looking for, and this will be the derivative. Look, if you bought u equals to 1 minus 4x squared, what will be the u? The du will be negative 8x dx. Look, x dx, here we are. We have it. So this is g prime dx. So for negative 8 is not a problem. If you have a number, if it is a matter of constant, it is not a problem at all. Divide by negative 8. But if it is a matter of variable, you cannot do that. So here we are. X dx, we will replace it by you can, if you want to find just dx, divide by du over negative 8x, if you want exactly dx. And you will come here and you will say, this is x over square root of u times dx. dx is du over negative 8x, and you will cancel this x with x. If you still have x here, you have to replace it by u. And of course, if you did that, you will have negative 1 over 8 is a common factor. You can get it out. And here we are. This is u to the power negative half, ya shabab, because it is in the denominator. Add 1, divide by the new power. When you add 1 here, it will be u to the power negative half plus 1 over negative half plus 1. Be careful. Negative half plus 1 will be a half. It will be just u to the power a half. Divided by half, it will be 2. So this is 2 square root of u. Simplify. You have this at the end when you replace u by its original. Always, ya shabab, you can check your answer by differentiation. So mistakes are not allowed here. Differentiate this. If you differentiate it, you will get this. Check that, please. Okay, I will let that for you. Here we have an easy exercise here, or example. The integral of e to the power 5x equals to e to the power 5x plus c. Am I right?
Yes.
Who said yes?
Me.
Muhammad Al-Amri.
Yes.
Okay, Muhammad. Do you agree, ya shabab, with Muhammad?
No, doctor.
No.
Okay, Muhammad. Let's check, Muhammad Al-Amri. Let's check our answer by differentiating, Muhammad. Yalla, differentiate this, Muhammad. What you will have? What is the derivative of e to the power 5x? It is e to
multiply by 5.
Multiplied by what?
5.
By 5 plus 0 to find the derivative of this.
Yes.
So we did a mistake. So this is not this is not the.
We should multiply by 1 over 5.
So what is the derivative, the integral of this one? It is 5 e to the power 5x. Is this correct?
Yes.
No.
No.
No, over 5, doctor.
Differentiate. If you want to check, differentiate. It will be 5 times e to the power 5x multiplied by 5. So you will have 25.
Okay.
So in that case, we should do the opposite. We should multiply by 1 over 5, e to the power 5x. Now, if we differentiate, we will get this. Look, if we differentiate, we will have this multiplied by this. If we take the derivative, it will be multiplied by 5, and this will be cancelled with this, and you will have it back. Of course, if you can do this, ya shabab, mentally, it is okay. I'm sure that after 1 week or 2 weeks from now, you can do it mentally when you solve so many problems. But to avoid this headache from the beginning, use substitution. Use u equals to 5x. This will means that du is 5 dx. Now dx will be a half or 1 over 5 du. Go to your integral, replace u by 5x by u and dx by 1 over 5 du. Now you know that the integral of e to the power u du is just eu, and this is 1 over 5 e to the power u. Substitute back, what is u? U is 5x, and that's it. Now let's go to another example, and here we have an interesting example now. Again, ya shabab, you need to be smart and start with a good substitution. What do you think, ya shabab? What is the good substitution here?
1 plus x square.
So when you have square root, so both what is inside the square root, what is inside the square root equals to 1 plus x squared. Now what will be du? du will be the derivative of 1 is 0, the derivative of x squared, it is 2x dx. Don't forget dx. Now what do you want? This will be, now this will be the square root of u, x to the power 5. This is a problem, by the way. So far this is not good at until now. Dx, so we can find x dx, but I need x to the power 5 dx. So what should we do in this case? I suggest in such situation like this, ya shabab, you have two options. One option is to write this as square root of 1 plus x squared times x to the power 4 x dx, because you have it here. But this is, of course, sometimes this will not come to your mind. So what you can do, now this will be, of course, ya shabab, if you divide by 2 here, if you divide by 2, this will be du over 2. And this will be, of course, x to the power 4, and this will be the square root of u. The problem here that we still have x, and this is not good, because u depend on x, and du is depend on dx. So we cannot integrate. We should have all of this here. We should have it as a function of u. So it should be f of u, a function of u, not of x. So to avoid this, what I suggest is to look what is dx. So divide by 2x. Now come here and replace, let me show it here for you. Come here, write this as square root of u, and this is x to the power 5. Keep it as it is for now. Now this is dx from here. Now simplify, you can cancel that x with that x. This one, it was okay, by the way, but if it comes to your mind that I mentioned here. Now, if you notice here how to deal with this, shabab, this is the trick that we need to learn now. What is it? How to replace this? How to write this? I need this to be written in terms of u, like h of u, a function of u. How to write this in terms of u? What is the relationship between x and u? Which equation here, ya shabab, give me the relationship
u equal
between x
1
and
plus
u?
x squared.
Here it is. This is the relationship between them. U equals to 1 plus x squared. So from here, we can see clearly that x squared, it is u minus 1. Just move this one to the another side. So x squared equals to u minus 1. What I want x to the power 4. So I will square both sides. So if you square both sides, you will have x to the power 4, and here u minus 1 all square. And this trick solved the problem now. Look, instead of x to the power 4, we will write u minus 1 all square du. What to do now, ya shabab? What is next?
Expand.
Expand this one, just expand the square. So multiply here. So you will have u squared minus 2u plus 1. Next, multiply, distribute by using the distributive property. Multiply this. This is u to the power 1/2, by the way. Just distribute it now. So this will be 2 plus 1/2, 5 over 2, 1 plus 1/2, 3 over 2, and this is 1 multiplied by u to the power 1/2, u to the power 1/2. Now integrate. You are ready now to integrate because you have sum and difference of two functions or three. Distribute the integral and integrate. In this case, you will just add 1 and divide by the new power. Take the reciprocal. Look at the trick that I told you about. Now, the last step, don't forget to do that. Substitute your function back. Replace u by what is it given from the beginning. Believe it or not, this long expression, its derivative is this. But of course, you need to do a lot of work to show that. Any question, ya shabab? This is very important example. You should learn the lesson here. What is the lesson that is that we have learned from this example is to make sure that all the expressions inside the integral must be in terms of the new variable u. So think about replacing your old variable with your new variable completely. Now, the integral of tan, how to find the integral of tan that I asked you at the beginning. If you notice that the integral of tan, what is tan of x? Tan of x, it is sine x over cosine x. This is clear. Now, what do you think? What is how to integrate sine x over cosine x? What is the best substitution to use here? The substitution is both this equals to u. Why? Because what will be the u? If u is cosine, what is the u?
Sine.
Again?
Sine.
The derivative
Sine dx.
of cosine is negative sine. Yeah, shabab, don't mix up between the derivative. I know that many of you, they will get confused about the derivative and the integral of cosine. No, the derivative of cosine is negative sine. So now you will go to we need here this will be u, and this will be du. Now just you have sine x dx. So what you need to do, just you will do this. This will be equals to the integral of cosine u, or cosine x is u, and sine x dx is negative du. So you can just write here -1 du. And the negative can go out, shabab. So you can write this. For me, I prefer to do it this way. Look what I will do. I will put u equals to cosine x. Du, I will not, this is okay. Forget about this. Du is negative sine x dx. So dx will be what? Dx will be du over negative sine x. I will come here. I will say sine x over u. And here dx is just negative du over sine x. Now this will be cancelled with this. The negative will go out, and the integral will be 1 over u du. And you know what is the integral of 1 over u? It is ln the absolute value of u. Substitute back. What is u? U is just the absolute value of cosine. So you will have negative ln of the absolute value of cosine. Now this is the integral of tan of x. We have a rule here. But usually, ya shabab, do you remember? Usually we prefer to link tan to a specific function. What is it?
Secant.
Secant, yes, secant. And you remember that secant x is 1 over cosine x. So in other words, if you put this negative by the properties of the logarithms, I think I did this here. Yes. If you just bring this ln inside, so it will be this to the power -1, which will be 1 over cosine, which is secant. So this is the rule that we have so far. The integral of tan x equals to ln the absolute value of secant x. And this is a new basic integral that you need to add to your table. So please update your table and add this integral to that table. Not only this integral, I want you also to think about what is the integral of cotan. The integral of cotan x, you can do it by the same way. Who can show me how to do this? This will be the integral of cosine x over sine x dx, and this we will put it as u. Sine will be u. What is the derivative of sine? It is cosine dx, so this will be 1 du. And in this case, we will have ln what? Ln u, ln the absolute value of u, plus c, which is ln the absolute value of, what is u? U is sine. So here we are. The integral of cotan is ln secant. How to write it in terms of cosecant? It will be negative ln cosecant x plus c. So you can also, shabab, add here that the integral of cotan x dx equals to negative ln cosecant x. If you want, you can write it in terms of sine, like ln sine x dx plus c. Also here you can write this, the integral of tan, in terms of sine, of cosine. This is all what we have for today, Shabab. Unfortunately, we didn't solve so much. We will continue tomorrow, inshallah. Not tomorrow, next class on Sunday. See you, inshallah, on Sunday. Have a nice weekend.